Hello, this is Esteban Madero presenting for Group 124, and this is our project, Edge Detective. Edge Detective is a C++ edge detection library with some pretty useful tools for processing images. Edge detection is everywhere from filters used on Instagram to satellite imagery and medical diagnostics, so it's pretty important. This is our TGA image header file. The program takes in TGA images. The pixels will be stored in a little pixel struct, a structure used for importing and exporting the image header and the information for reading the file. And then all the pixels will be stored in a vector of vectors, which is essentially an adjacency matrix for processing. Important functions: loading in an image, exporting an image, and getting the header information so you can write it out correctly. Convert to grayscale is going to normalize the pixel values into their respective intensities using the luminosity approach, which takes into account human perception. Gaussian blur uses a concept called convolution, which defines an element based on its surrounding elements. This is going to do a Gaussian ratio, so it's going to sort of blend things together. Take out some of the noise. Pruitt edge detection and Sobel edge detection both do the same thing. You're going to use convolution to sort of define horizontal and vertical edges and then find the magnitude of them together. Canny edge detection will extend the Sobel edge detection through these three functions down here: non-max suppression, double threshold, and hysteresis, and we'll go over that in a second. So once you run the program, it uses SFML for this little nice little graphical user interface. You can load images into your input file that's included, type in the name here and load it in, and then you can hit these and it will give you the Canny edge detection and the Pruitt edge detection, which are the algorithms we're comparing today. You can see Canny is a little more defined and has more harsh lines. Pruitt edge detection is a little more puffy and a little more loose. So that's not all. We'll go over to the command line interface now, and you can see that you have access to all of these individual functions. You can access them individually if you wanted to, so you can sort of mess around it and get an idea for it. So we're going to load another image, this car image here. I'm going to be analyzing this. So I'm going to go ahead and export it right away. I know I just brought it in. And just to show you what happens when you load an image in, it's going to automatically grayscale it for you, because one of the prerequisites of doing edge detection is it's independent of color and only based on the intensities. So it's going to go ahead and grayscale it for you automatically. Next, we're going to apply a Gaussian blur, called Gauss.tga. Also a prerequisite just to sort of eliminate some of the noise, and you're going to see kind of blurs the image a little bit, kind of melts the intensities together and kind of softens the noise. Next thing we'll do is we'll run the Pruitt algorithm, which is going to convolve around a horizontal and vertical axis and sort of define the edges and then combine them together to find the angle. And we already looked at this image before. You see, and then we're going to go ahead and load the image again, and we're going to go down the Canny approach real quick. So Canny approach is the same thing. We'll apply the Gaussian blur, which is part of it, and then we'll apply the Sobel algorithm, which is the same exact thing as the Pruitt algorithm, but it's going to give a more of an emphasis on the immediately adjacent pixels. So you can see it's kind of more intense. The lines are more defined, but also there's a lot more noise going on in the picture. So the way we handle this is using a concept called non-maximum suppression. And what that's going to do is sort of go through the pixels and look at the angle at which the edges propagate and sort of compress them together. So we'll look at that real quick. So suppression, boom, you can see it kind of narrows the field together, but you still got a bunch of different pixel intensities, so we want to try to define these lines a little more. So we're going to use something called double threshold, and what's that going to do is going to set a high and a low threshold, and the pixels that are above the high threshold will be set to the strongest intensity. In this case, it's 255. Ones below the weak threshold are going to be dropped from the image, and then ones in between them are going to be set to weak. So if you sort of zoom in here, you can see all these light gray pixels and then all these bright white pixels, which are strong pixels and are weak pixels. And then last, we are going to remove all of the weak pixels through a concept called hysteresis, and we're going to compare it to its adjacent pixels. And if it touches a strong pixel, it too becomes strong. If it doesn't, then it's dropped from the image. And this will be the final image. You might recognize it as the same canny image from before. We also include a convolution function for general convolution, so you can add your own matrix if you wanted to and see what that does. And that's our project. Thanks for watching. Check out the GitHub.